Okay, so we are going to start with a kind of review of transformations, which is back in, we do it in Unit 2 in Geo A, where we talked about rotations, reflections, translations, that kind of thing. We're going to kind of dial it back to dilations. And dilations were when objects got bigger and smaller from multiplying them by a scale factor. So, a vector is a quantity that has both direction and magnitude. Oh yeah, that was the famous. Oh god, grew from Despicable Me. You remember the guy in orange? His name was Vector. He talked about direction and magnitude. So what's happening is you are traveling in a x direction and a y direction. So if you think about going back -2 and then up +3, this becomes your vector that you're traveling. And I know I kind of cross lines a little bit there, but if we go left 2 and then up 3, let's do it. Yuck. It's been a minute since I've written on my board. So we go left 2, up 3, and this becomes our vector that we're creating. This is our initial point and our direction. Okay, so what we're going to do with that is take that -2 to all of these, to all of these, to all of these. Okay, so that will become 0, that will become 1, this will become -6, and this will become -7. And then we're going to do a +3 to all of them. +3, +3, +3, and that's going to give us 4 here. That's going to give us a +1 there. That's going to give us a +6 and a -1. And we have just taken this object, whatever it is, the pre-image coordinates, and there's 4 of them, so I guess it's some kind of quadrilateral. And we're going to shift it left 2 and up 3. And we're going to get that same, whatever shape it is. Maybe it's a trapezoid, okay? I don't know, because I'm not doing it to scale, but you can see that it's traveled 2 units to the left and then up 3. That's doing our vector. So when we look at this, you have to go from one letter to that exact same letter, and you should always travel in the x direction first. Even if it crosses over into your picture, you should always do the x first. So we're going to jump 2 spots to the right. So that's going to be a +2 in the x direction. Then in the y direction, we're going to take that and go down 2, 3, 4, 5. So we're going to go down -5 because we hop 1, 2, 3, 4, 5. -5. And that becomes our vector for that as well. So you're traveling, you're taking this picture and you're shifting it and translating it 2 to the right and down 5. And that's what that says. And that's the practice we want you to get good at. So when we go here, our A to A prime, so it should always go we call this the pre-image to the prime. There's the prime image. What are we doing? So to go from A to A prime, we are traveling 1, 2, 3, 4, 5 to the right, and that's a positive direction. And we don't go up or down any, so that becomes 0. We're just shifting it 5 to the right. And if you do that for each one of these points, you're going to see that you will wind up with that same figure just shifted 5 slots over. So, for our reflections, choose your own adventure. We can either do it by learning the rules, which you can very well do, but I just want you to think about, what if we were to flip it over this, or fold it over this, fold it over that green line? What are we doing? Well, then K comes here, and we call it K prime. L comes here, we call it L prime. And then M is going to be 1, 2, 3, 4 away. 1, 2, 3, 4 away. And this becomes M prime. And this is our same figure, just flipped over the x-axis. So when we reflect it across the x-axis, This is quadrant 1, so that's what we need to do. We're reflecting it across the x-axis. Now, do that same idea, only this time we'll use the other axis, the y-axis. So let's flip it over the y-axis. And if we do that, we're 2 here, 2 there. We are 1, 2, 3, 4 away, 1, 2, 3, 4 away, and we'll call that L prime. This is K prime. And then 1 away, this is M prime. And now we need to figure out what quadrant we are here. So this is 2, and then this is 3. And then this is the 4th quadrant. Okay, so if we're reflecting across the y-axis, that goes and moves it into the 3rd quadrant. Now, if we reflect it across y equals x, which means, we're reflecting from one corner to the other corner of our graph. So we could look at 1, 1, 2, 2, 3, 3, 4, 4, 5, 5, 0, 0, and we reflect across that line. Now, I'm not going to keep these lines here. Do not think they are necessary. We know what y equals x is looking like. But if I flip this picture over that line, instead of going, you want to fold it over. So 1, 2, 1. So we are going to do K. Watch what happens. Oops. Sorry, I don't have my pen. So let's look at K. K is going to be 2, 1. So we go right 2 and then down 1. Well, what we're going to do, and that's a negative, we're going to flip-flop this idea. So whenever you reflect across y equals x, we're just going to flip the x and the y. So instead of going right 2, down 1, we're actually going to go left 1, up 2. Oh, my whole picture got shifted. Oh, what happened? I don't like this at all. What happened? That's better. All right. So let's go back to K again. K was right 2, down 1. So 2, negative 1. So that means we're going to go left 1, up 2. And that becomes our K prime. So we're just going to flip-flop. So negative 1, 2 is K prime. Then we're going to do L prime. So L is 1, 2, 3, 4, 4, negative 1. So that means we're going to do negative 1, 4. So then we're going to go left 1, up 1, 2, 3, 4. And this becomes L prime. And then M is going to be 1 and then 1, 2, 3, 4. 1 and then negative 4 because we go down. So we're going to go left 1, 2, 3, 4, up 1. And that's going to be, M prime. And when we do that, that's our triangle, which is a reflection of y equals x. So memorize how to turn them around. I don't care. But if you think about just reflecting it and knowing which one is 1, 2, 3, 4 for the quadrants, I think is going to be probably the biggest thing is memorizing which quadrant it is. So if we reflect it across the x-axis, you are turning whatever the y is to the opposite value. Because when you think about it, here's our x-axis. So if it's up here, it gets moved down here and then vice versa. The x values don't change. So 2, 3, negative 4, -5. The x values don't change. We just change the y's to be the negative. Then this one's going to be positive. This one's going to be negative. And then this one's going to be positive. So you just alternate whatever the sign is for the y value only. For the y-axis, what we're doing is whatever this dot is, we're just going to move it over on this side. So the y value stays whatever the y value is. If it's 1, it's 1. If it's -5, it's -5. Whatever this y value is stays consistent. So we can copy down all the y values. 3, and then -4. And then the only thing we switch is the x value to be the opposite of whatever it is. So if it's positive, it becomes negative. If it's negative, it becomes positive. And then this one, if you remember it, it's probably the easiest one. You just flip-flop the x and the y. Is we just do, oh, that's y. I'm looking at the wrong ordered pair. So this is -2, this is 3, this is 3, this is -4, this is -4, this is -5. You just flip-flop the x and the y. All right, so skim scan. What are we doing for rules of rotation? This one, I think the best way to do it is to either get that tracing paper that you can rotate, or you start to turn your screen, because I think that's the best way to do it, especially trying to understand this stuff. Memorizing these rules works, but when do you get it confused with the other, with reflections, and how do you know which one's which? I don't know. That one's a tough one for me. So you have to do what works for you. We can't ever do anything that doesn't work for you, or there's just no retention there. So what I like to do is, especially for 180s, if I see it at one spot, I'm going to rotate it to the other spot. And I'm just flipping this to the other side, flipping this to the other side. So it's tough, but this is a rotation of 180 degrees. This is just a one spin. We're going from one quadrant to the other, so this is 1 to 4 in a clockwise progression, because we know this is noon, 3, 6, and 9 o'clock. So as we go in the clockwise direction, that's going this direction. So each one of these turns, whether I go from here to here or here back to here, is 90 degrees. 2 turns is 180, 3 turns is 270. So like this one, we turn it back counterclockwise, 90 degrees, or clockwise, 270. And we could say the same thing here. Clockwise, this is 90 degrees. Counterclockwise, this is 270. And we would get back to the same picture if we spun this back 1, 2, 3 spots. Because 1, 2, 3. Because we'd have a triangle here, then a triangle here, and then the last one gets rotated back to there. And then last but not least, dilations. Dilations is an enlargement or a reduction. So if the number is larger than 1, it's an enlargement. If it's less than 1, it becomes a reduction. But it's between 0 and 1 is the reduction, because negatives do a whole new game. Okay? So what we're going to do is just multiply the x and y by 3. So 6, 3, 3, -12, 9, -6, and that's it. And then you would plot these points and you would see it 3 times as large. This one will be half the size, so this would be -1, 2, 2, 4, 5, -6. Most of the time they will probably give you nice clean numbers, but use a calculator. Figure it out. I mean, that's not too tricky. So for this one, we would want to find a side and put it over a side. Put a side over a side. And you should always go, what would it be? Image to pre-image. Image divided by pre-image. because what's happening from the black to the blue, it's getting bigger, right? So the bigger number we would want on top. So this would be like a 1, 2, 3, 4 and a half. I'll call it like 4.5. And then this one would be 1, 2, 3. And if you do 4.5 over 3, it's a getting bigger by 1.5. So a factor, it's enlarging by a factor of 1.5. Here we can do this and this. Sometimes they're as clear, sometimes they're not as clear. Do the best you can with what you got. But I see this being a 1, and that's the image. So 1 goes on top, and then 1, 2, 3, 4 goes on the bottom. So this is a reduction by a factor of 1/4. And you can even call it, to be proper, a scale factor of 1/4. These two, because they are diagonals, you could build it into a Pythagorean theorem problem and find the diagonal. Or we could just say B is 1, 0. B prime is 2, 0. So if we do the image over the pre, we are going to get 2 over 1. So this is a scale factor equal to 2. And I think you would see that if you were to calculate this like 1, 2 hops, you can see 1, 2, 3, 4 hops through that diagonal. It's kind of a clean diagonal that they drew, so that does help us a little bit. But if you're unsure, make the Pythagorean theorem. Like if you really want to be exact and get the perfect answer, that's what you're going to do. You're going to go, I'm building the Pythagorean theorem. This is 1, 2, 3. This is 1, 2, 3, 4. So I know it's a 3, 4, 5 triangle because that's your typical triangle. And then we're going to do 1 1/2, it looks like, and then go up 1, 2. So our other triangle, our blue triangle that's inside of that, if we were to build it, this will be 1.5, this will be 2. So we will do Desmos graphing calculator. We're going to do 1.5 squared, 1.5 squared plus 2 squared. So that equals 6.25 squared. So then we are going to do SQRT 6.25 and get 2.5. So this becomes 2.5. And if we do the image divided by the pre-image, and remember the image is the regular ones, the image is the one with the primes on it. So that's the blue one. And then the pre-image is the one we start with. So we are going to start with the black. This 5 goes on the bottom, and then 2.5 goes on top, which that's a scale factor of 1/2. And if we look at n to m, what is that? -1 comma or 0 comma -1. Let's write it correctly. So n prime is 0 comma -1, and n is equal to 0 comma -2. So if I were to put prime over pre, I would get -1 over -2, which comes out to be 1/2. Now you can't always rely on the ordered pairs because sometimes it will throw you off. So be careful with the ordered pairs. Make sure both of them are the same. because that can get a little tricky, and I don't want that to happen. So I think that about covers the review session of transformations. We are going to go on to proportions next. Let's take a look. Proving similar figures with transformations. Okay. So, thank you for watching, and I hope that helps.